Yes, hello. Well, so if your Python code is slow, there's a simple solution. You can just rewrite it in Rust, right? well, that's maybe a bit too much, but you could write part of it in Rust. And my name is Miikka Koskinen. I'm a software engineer, and I work on these systems for processing a lot of data, usually in Python. But I've found some opportunities to use Rust as well. And the last was, or the first time was a year ago. We were working on this time series database in Python. And my coworker, he was looking for an interval library. And there are options for Python, of course, but for various reasons, none of them were quite right for us. And, well, turns out there's this Rust library that was just perfect. And my coworker, he asked the obvious question that, well, why don't we just use it? We could write some bindings, you know. And we had just done this project in Rust, so we knew Rust, but I was kind of hesitant because my idea of what it is like to extend Python in other languages was like this. This is C code for a function that takes a list of numbers or list of ints in Python and calculates their sum. So it's just a toy example, but gives you an idea. And I don't know about you, but for me at least, it's kind of hairy. There's lot of things going on. And it's the sort of code that I can write if I need to, but I don't really want to. But my coworker, he went ahead and made this proof of concept, and it was more like this. So this one I kind of like. It's sort of high level. Even if you don't know Rust, you can probably kind of see what's going on there. It is calculating the sum of list or vector of integers. So that was like lesson learned for me. Extending Python in Rust is actually like fairly easy. Like there's no catch. And that's what we are going to talk about today. So we will start with like why Rust is interesting for Python people, and then we are going to look at a couple of tools that you will need, like how to get started. This won't be a tutorial, but just something like you have to go, once you go home, you want to try this out, you know what the tools to use. Okay. How many of you have never heard of Rust? Yeah. It is pretty well known by this point. But it is a systems programming language, so like you could write kernel in it or web browser. Microsoft apparently is writing parts of Windows kernel in Rust nowadays. It's been around for a while, getting pretty popular. But okay, the Python perspective. Why would a Python person care about it? And the big thing is that it's fast, right? Python is many things, but it is not fast. Like, it is fast enough for most of us, most of the time, but when you are doing heavy lifting, then you will run into problems. And because Rust is systems programming language, it needs to be fast. It's right there with C and C++. There's endless debates which one of them is the fastest, but it's anyway, that's the highest tier of performance. But it has other good things going for it. So it is a nice language to use. It's not quite functional programming, but it does have pattern matching, powerful type system. It's not object-oriented either, but there's structs, enums, traits, which are sort of interfaces. So in the keynote, Hynek mentioned the Rust style of writing Python. So if you are using strict type checking, and you are using data classes or maybe others everywhere, then you might find yourself to be home with Rust. The other big thing it has going for it, unlike C, it enforces memory safety. So if you have programmed C, you know that you have to allocate memory and then free it. And if you don't get it just right, your program will crash or it will do other nasty things. And Rust solves this by checking it at compile time. And I have to admit, at least for me, there was a bit of a learning curve to learn how to structure my programs so that they can be checked. But it is still much nicer than the crashing. The compiler is helpful there. There's been this movement of actually making good error messages, and Rust compiler is pioneer there. There's good tools like Cargo, the build tool. And the community is active. There's a lot of going on, a lot of open source packages. They are called crates, and events, online communities, so on. And yeah, the Python community has picked it up, as has been mentioned during this conference many times. I have this list of couple of big name Python libraries with significant parts of Rust in them. Cryptography, Polars, it's a data frame library. Pydantic for data validation, or JSON for JSON parsing. And for all of them, the performance is a big part of why they have made this design choice. For example, Pydantic version 2 was rewritten, the core was rewritten in Rust, and they say that they get 17x performance improvement on average on their benchmark suite. And of course, just using Rust wasn't the only thing they did. They designed it for performance, but still programming language helps. So, you know, if you want to be trendy, there's this thing going on where people are writing their Python library course in Rust. So it's time to jump on this train. Well, let's look at then how to do it. First of all, there's this small task of having to learn Rust. I'm not going to say much other than there are a lot of resources out there. You can go to the Rust website and they, for example, have this free book, which is good if you are an experienced programmer. But there are also other books, YouTube videos, tutorials, online exercises, and lots of things. So just go find something that works for you. And we are now going to focus on the Python stuff. So when you extend Python in any of these compiled languages, C, C++, Rust, what have you got, you need a couple of things. So you need to use Python's C API, which you could do directly in Rust. But we saw the C example. It was hairy. But luckily, there's PyO3, these bindings for Rust, that makes it much easier. And then you have to actually compile the code, of course. And for that, we have a couple of tools in Python community. There's Maturin, and there's Rustimport. They are a bit different. I think they are both great, and that's why I'm gonna show you them both. But let's start with the bindings. So, why do you need them? So, when Python calls your Rust code, it gives you the Python data structures, like dicts or arrays, lists or what have you got. And you have to use Python's code to interact with them, like, for example, to add an item to the list or what have you got. And like I said, we could do it directly, but we can do it an easier way. So here is again the same example from we saw once again, or already, but this time expand expanded to be so that you can compile it. So the big difference is that what PyO3 does, that it converts the Python types to Rust native types. So you are not getting like Python list or PyList, but you get this vector which is Rust native sort of list. And you are not getting Python ints, but you get I64, which is like 64-bit integer. So this means that when you are in the Rust world, you can write this idiomatic high-level Rust instead of having to do the type conversions and everything manually. Now, if you want to do it, you can do it. You might need to do it sometimes for performance or for certain kinds of API design. It's possible, but you just change the type annotations for your function and you are good to go. So there's the function, but then you also need to register your code with Python so that it knows that what functions you have. So you have to do this bit of boilerplate where you define a module and add your function there. You could of course be defining classes, or if your module would have a state, you could do that as well. But that's PyO3. It's great. Then you have to compile your code. And for that we have Maturin. It's a build tool, Python packages implemented in Rust. So there's command line tool. You can create a new package. You get this fairly familiar looking structure. There's pyproject.toml. There's your code, cargo toml for the Rust build tool. And what this does is that you can go and run Maturin build, and you get a wheel. So you can upload this to PyPI or your company internal Python package registry, or you can just install it. And if you don't want to use Maturin itself, you can use it as a build backend. So if you are using UV, if you are using Tox, it integrates with this standard Python ecosystem, so you again can use the tools you are already familiar with. So this is good if you are creating a library. But if you just want something simpler, then we have the sort of magical choice of Rustimport, which plays tricks with the import statement, and you can do this sort of thing. So on the left, there's your Rust code, myrustmodule.rs, and there's the magic command, rustimport PyO3, which tells that this is PyO3 code. And then on the right, you have your Python code. And first you import the Rust import hook. And then you do import myrustimport module. And the import hook, now this is based on the module name that you are trying to import the Rust code. And it goes and calls cargo to compile it and load it. And bam, you can call your function. And what this means is that then when you want to edit the code and you do some edits, you rerun the script, it compiles it again, and your changes are there. Or if you are using PyTest for unit testing, for example, again, just edit the code, rerun the tests, and changes are there. So this gives this very familiar development experience. At least that's how I develop most of my Python code. I just edit it, and then I either run the script or run the tests. So which one to use? If you are going to publish a package, Maturin for sure. If you just want to put some Rust in a file and call it from Python, like experiments, Rustimport. But otherwise, you'll have to use a bit of judgment. If you go back to my coworker and the interval tree, so he actually used Rustimport, and when we were going to merge it and go to production, I was like, maybe we should look into Maturin, like not have this magic tool, but like this explicit serious tool, but turns out that Rustimport has this release mode where you can pre-compile your code when you are building like Docker image or something, and then it disables the compilation so it won't happen in production. And yeah, that actually works great. So we ship the Rustimport thing, and it's probably right there processing like thousands of requests per second right now. So that's also an option. Another cool thing I did, I was doing these compression algorithms in Rust, mostly to learn them. And for that sort of code, it's great to have property-based tests. And in Python, we have Hypothesis, which is this very nice library for that, really state-of-the-art. So I just installed Rustimport and Hypothesis, and I made this quick wrapper for my algorithms. And then I just had Hypothesis tests for it, like almost for free, like 15 minutes of work. And as usually happens with Hypothesis, found quite a few bugs in there. Well, after you invest all this effort, will your code be fast? And it's like, if it's CPU-bound code, it will probably be faster, but I can't give you numbers. You will have to benchmark it. Like, that's just how it always is. And yeah, that's all the slides I've got. My name is Miikka Koskinen. The slides are there. You should read my blog as well. And sort of to recap. So Rust is a great language for extending Python because it's fast, it's nice to program in, and the tools are good. So I hope you will now go home and try this all out. Thanks. I guess we have a bit of time.
Yeah, we've got enough time. Yeah. Are there any questions? Yeah, just at that.
Thanks. Any regrets from choosing Rustimport with the release option?
Sorry?
Any regrets from choosing Rustimport with the release option? When would you not want to use it then?
No. It was great. I don't think you can build like wheels with Rustimport, so maybe don't try to do that, or maybe it's possible. But otherwise, yeah, it's excellent.
In your example on the slide in Rust, you were using a sum function.
Yep.
And it took a array, list, vector, don't know the term, of 64-bit ints and outputted 64-bit int.
Yeah.
What does it do if Python feeds it something bigger than that?
So I think you will get type error. I haven't checked, but the type conversion code in PyO3 checks the types that are coming in, and then if you feed it wrong sort of data, it will give an error.
Even if the input is an int, but it's outside the bounds of 64-bit?
I don't know from top of my head, but I would think that that's what happens.
Have you sort of found any feature creep where you've implemented more and more in Rust, or do you know where to keep it partitioned to Python versus Rust?
Yeah, that's a good question. I haven't really run into feature creep, so tough to say. I guess there's this thing where you have to start dealing more with the smart pointers and the memory management stuff, where it starts to get, you will have to learn more about Rust and more about PyO3 and the Python C API, and then it starts to feel a bit less nice, so maybe that's like, there's natural limit to it.
It's like premature optimization, isn't it? You don't want to optimize without benchmarking
Yeah.
You want to make sure you optimize on the things that need to go first.
Yeah.
Can O3 work with Python classes then to wrap them, or?
Yeah, yeah. You can define Python classes with PyO3, certainly. I don't have any examples, but if you go to docs, you will find out how to do it.
Great talk, thank you. In terms of debugging, so obviously, you've got some bits of your code might be in Python stack trace, some of it might be, sort of Rust issues. What have you found it's like where, you've got issues that might kind of go from one to the other and like tracing through? What's the tooling like for that?
Well, I have to say that I've been lucky enough to not run into many deep problems, so I can't much say about that. I've tried to keep my Rust code sort of contained so that there's not much back and forth between Python and Rust in the stack, so then you just get fairly straightforward error messages.
Does normally in Rust you put the tests in with your code side by side and then Cargo runs the tests? Are you able to do that with your PyO3 stuff?
Yeah, you can put it there and you can use Cargo test. I think it's so. I kind of prefer to do the testing on Python side when I'm using both Python and Rust together. I feel that's maybe more natural, but if you want to do it on Rust side, you can do it with the standard tools.
Hi. You mentioned that you took an interval tree library from Rust and exposed it to Python. Did you find that there was much of an impedance mismatch? Like, did you have to change the API to get around Rust's use of discriminated unions, or did it come over quite neatly?
So we didn't really do like full bindings, but we just exposed the part that we really needed customized for us. So we didn't really run into that problem, but yeah, it's possible that that would happen. I don't think you can take like any Rust library and just write bindings. That's going to be a problem.
Hi, thanks for the talk. I know nothing about Rust, so apologies if the question is silly. So I think you imply that if we have a CPU-bound application, then Rust is the way to go. But what about memory-bound and I/O bounds? Would you go there in implementing Rust for these such applications, or take another route?
Yeah, that's a great question. Well, for memory-bound, maybe you certainly have more control over what you are doing if you are going with Rust. For I/O bound, together with Python, I can't say from top of my head, like, if the problem is I/O, then just using Rust won't directly help with that. Maybe it could be part of the kind of the larger design, but you will have to think about the I/O first and then figure out what to do with Rust there.
I think this is the last one.
So you have an existing Python project using like, setup tools and want to introduce like Rust extensions to it using like, Maturin. Is it possible to do without introducing too much complexity to the build process?
Yeah, I think like the straightforward way to do it is so that you sort of set up a new Maturin project and put your Rust code there, and then add that as dependency of your main Python project. And then you sort of have separate build processes for them. I think that's pretty typical setup. It's slightly complex, but I don't think it's too bad.
Okay, I think that's all we have time for, so please thank Miikka again.